Good morning everyone. Today I am going to discuss solar thermal energy, right, which is a topic from the unit 2 of the renewable energy resources. So in solar thermal energy I will talk about the solar radiation, about the flat plate collectors and the materials, what are the applications used in from the flat plate collectors and the performance of the flat plate collectors. And then I will focus on the collectors, on their materials, again application and the performance. Then the types of solar thermal power plant, introduction about the solar thermal power plant, right, what is thermal energy and what are the what we can use as a storage for the solar heating and cooling, and what are the limitations. I'll going to discuss all these matter in this lecture. So starting with the solar thermal power plant introduction. So basically it uses mirrors, right, so as to collect the sunlight and to produce the steam. After collecting the sunlight from the sun by using the mirrors, the steam will be produced by solar heat, which help to drive the turbines and which can in turn generate the power. So this system basically generates power by the rotating turbines, just like thermal and the nuclear power plants, like. So therefore it is suitable for the large scale power generation. So these are the solar radiations you can see here. The solar radiations are the actually electromagnetic radiations which are ranging from 0.25 to 0.45 micrometer, right, in wavelength. It also includes the ultraviolet, visible light and near infrared radiations, right. These are the solar radiations, and the common units which are used for the electromagnetic radiations in wavelength are the angstrom, nanometer, micrometer, millimeter, kilometer, right. 1 angstrom is equals to 10 raised to power minus 10 meter. 1 nanometer will be equals to 10 raised to power 9 minus 9 meter. 1 micrometer will be equals to 10 raised to power minus 6 meter, and 1 millimeter is equals to 10 raised to power minus 3 meter, while 1 kilometer will be equals to 1000 meter. Okay. So you can see these are the solar radiations, the three radiations, near infrared radiation and the near ultraviolet radiations we cannot see, only the wavelength between 0.3 to 0.7 will be the visible light which we can see, and the solar spectrum includes from the visible light to the near infrared radiations. Okay. So you can see here there are the total rays of the solar radiations will be the gamma rays, the X rays, the ultraviolet radiation, the visible ray light which is visible to us, right, infrared radiations. It also includes the microwave which is ranging from around 100 micrometer to 100 millimeter. Then there are short radio waves are also there are AM radio waves are also there, and there are also long radio waves which ranges from 10 raised to the power 3 meter towards the 10 raised to the power 5 meter. Of all these radiations of the solar radiation, only the visible light is available, will be visible to us, and it ranges from 0.3 micrometer to 0.7 micrometer. Okay. So you can see here the solar radiations. Basically some of when these radiations are are on the mirror, reflected on the mirror, then some of the radiations are reflected back, and some of the radiations will be diffused radiations, and some of the radiations, these are the direct radiations, these are the diffused radiation, and these are the reflected radiations which are going to the mirror, right. Okay. Now talking about the flat plate collectors, you can see here these are the flat plate collectors used on the top of the roof, right. So what are the flat plate collectors, solar collectors? These are probably the most fundamental and most studied technology for the solar powered domestic hot water system, right. The overall idea behind this technology is very simple. The sun heats this dark flat surface which collect as much as energy which is possible, and then energy is transferred to water, either air or to fluid, for further use. Okay. So this is the very simplest concept of using the flat plate collectors. We can trap the solar energy and used it for further generation of the electricity. Okay, so the components used for the flat plate collectors are the black surface, the glazing cover, the tubes and the support structure along with the insulations. You can see this is the process through which we are collecting the solar energy from the sun using the flat plate collectors. The black surface is behave like an absorbent of the incident solar radiation, right? Then talking about the glazing surface, right, glazing cover, it is a transparent layer. You can see over here, this is a transparent layer, right, which transmit radiation to the absorber and then prevents radiative and convective heat loss from the surface, right? Then these tubes are used here for the which are containing the heating fluid so as to transfer the heat from the collectors, right? Then the supporting structure is there. The supporting structure is used to protect the component and hold them in their places, right, which also including the insulation, right? This is the insulation insulation sides at the bottom so as to reduce the heat losses, right? This is the black absorber plate used over here. Okay, the solar radiations are first incident on the that black surface, okay, which will work as an absorbent and then of the incident solar energy, right? So this glazing cover, which is a transparent layer, actually it will transmit radiation to the observer and prevent the radiative and the convective heat loss from the surface. Then these tubes will be containing the heating fluid and they transfer the heat from the collector. The supporting structure is used to protect the components and hold them on the place. Also it is containing the insulation, right, at the bottom and the sides as well. You can see here, this is the thermal insulation at the side and the bottom so as to reduce the heat losses. So basically these flat plate collectors are divided into two categories according to their use. First one is the water or liquid heater, another one is the air heaters, right? So basically these are used, and finally these are subdivided into another parts, like a flat plate collector is two types, water or air heater, right? Water and air heater. Then further water or liquid heater is divided into three parts, and similarly air heater is divided into three parts, right? So in case of water or liquid heater, the first one is the pipe and fin type, another one is the water sandwich type, and the last one is the semi sandwich type, right? And in case of air heater, it is finned plate, either metal matrix or you can say corrugated plate with selection surface. I will discuss by all these flat plate collectors one by one, okay? So first of all, the three categories according to the temperature of the flat plate collectors are the low temperature collector, medium temperature collector and the high temperature collector, okay? So low temperature solar collectors are typically unglazed flat plate collectors, right, which are intended to operate at a temperature only at 5 to 30 degrees, right, which is above the ambient temperature, right? So these low temperature liquid collectors are basically used for the swimming pool heating, right? With the light glazing and the enclosure, they are basically used as air collectors for agriculture, low temperature application such as the crop drying, okay? Medium temperature collectors basically are the flat plate collectors which are enclosed in an insulated case, right, with one or two insulating glazing, okay, and glazing, sorry. The intended temperature range of these medium temperature collectors is from 15 to 200 degrees Fahrenheit, which is above the ambient temperature, right? For the lower end of this range, single glaze collectors with non-selective absorber plates are most cost effective, right? And in the middle and high end of the range, the selective collectors with one or two glazing plates are most cost effective, right? So the typical application for the medium temperature collector will include the water heating, space heating, and sometimes industrial heating is also use these medium temperature collectors. Now, when we talk about the high temperature collectors, the temperature, these include some overlap from the flat plate collectors in the medium temperature range with the selective absorber plates, okay, and heavy insulation, okay. So they may have temperature capabilities enhanced in installation, which is being mounted in a sun tracking system. So these are the three categories based on the temperature. And now talking about the solar cell. So basically these flat plate collectors are having the advantage over the other types of collectors, right. So first one is they absorb direct, diffuse and reflected components of the solar radiations. All the three types of the radiations they are absorbing, right, because of the black surface. They are fixed in tilt and orientation, and thus there is no need of tracking the sun. Okay, there is no need to track the sun continuously because they already fixed in the tilted position, and the orientation is also fixed, as I have shown in the previous slide as well. So they are easy to make and are low in cost, right, and the comparatively low maintenance cost is required, and they have a very long life, and efficiently obviously they operate at very high, comparatively high efficiency as compared with the other solar energy collectors. Now, what are the solar power generation? There are two ways of generating power energy from the sun. One is the photovoltaic, another one is the concentrating solar thermal, right. In case of photovoltaic, we are converting the sunlight directly into electricity, while in case of these concentrating solar thermal, they are generating the electricity indirectly, right. Sunlight is not converted into electricity directly. By using some other means, we are trapping the solar energy, and then using those other processes, we will convert it into the electricity. Now, what about the history? Okay, so in 1866, Mr. August used a parabolic trough to produce the steam for the first solar steam engine, okay. While in 1886, the first patent for the solar collector was obtained by the Italian Battaglia in Genoa, Italy, okay. And in 1913, Mr. Schumann finished a 55 HP parabolic solar thermal energy station in Egypt for the purpose of the irrigation. And in 1929, the first solar power system using a mirror dish was built by American scientist Dr. R.H. Goddard, right. In 1968, the first concentrated solar power plant, which entered into operation in Italy, right. And in 1981, the 10 megawatt solar power plant tower has been developed in Southern California, right. In 1984, the parabolic trough technology of the solar energy generating system began its combined capacity of about 354 megawatt, right. While in 2014 now, the largest solar thermal power plant of the capacity of around 392 megawatt achieved the commercial operation in California, USA. Okay. So these are the solar thermal system. Basically, these are of two types, active and passive. So a passive system, it requires no equipment, like when heat builds up inside your car, when it's left parked in the sun, right. So for example, thermal chimneys. In case of thermal chimneys, no equipment is required, only heat is trapped itself. In case of active system requires some waste, so that we can collect and absorb the solar radiation, and then we can store them. For example, solar power plants, thermal power plants, right. That's all for today's lecture.